Hey everyone, welcome back to Papa's Workshop. I've got a different kind of video today. I was actually in the process of working on a project when my table saw literally blew the breakers, shut down, and stopped. Well, it's going to be a problem with the motor. Now this motor was rebuilt completely about 25 years ago and has been fantastic this whole entire time. But I guess it's time for it to give out and break again. This saw that I've used is over 50 years old. Now this is going to create some very interesting projects for me because I'm going to completely tear this saw down, clean out everything, grease and oil all the different moving parts, because one of the things, it does squeak when you raise and lower the blade or tilt the blade. I'm going to get all of that taken care of, and for the first time ever, I actually bought a dial indicator. Now I want to make sure when I put the table saw back together that it's aligned perfectly with the saw blade itself. I even bought a brand new saw blade. So I'm going to have a brand new saw blade. I'm going to have this dialed in with a dial indicator so it's perfectly parallel. I'm putting new belts on it, even though I really don't think it needs it. But you know what? Now's a good time to put them on and have a completely rebuilt motor in a few days. I've already dropped that off at the electrical motor shop, so they're working on it. So a lot of things are happening, but it definitely killed a project and it created a new project. So this is how it began. I was cutting a half-inch piece of the MDF melamine material, and it was going just great until this happened. Right there you could see just a little flicker in the camera, and you could maybe barely hear it, but the breaker tripped and the saw is now dead. I turn it off, I turn it back on, and nothing. And of course, I reset the breakers and still nothing. Well, as you might expect, there's going to be a lot of sawdust underneath that table that you just can't vacuum out on a regular basis. In fact, I think there's some sawdust here that's probably 50 years old, if not older. But these are the places where the bolts hold on the top itself. It's only 3 places, and the third one is right there. When you get those 3 bolts off, then I could slide over this very, very heavy tabletop. I must say I did not expect this much sawdust to be accumulated underneath that tabletop. But the first thing is I want to be able to get the saw blade out of the way and start cleaning everything on this machine. Now there is nothing light about any component on this part except maybe the saw blade itself. The tabletop itself is so heavy I cannot physically lift it. That's why I had to slide it out of the way onto the workbench. But at this point, I can start actually cleaning and get all of this sawdust out of here. Now there's no sawdust down at the bottom of the saw. I clean that out on a regular basis. But like I said, I had no idea all of this sawdust was hiding up here underneath the table. So I'm going to take a few minutes and get all of this vacuumed up and cleaned off so I can actually see the different components so I can start making some repairs. You can see the 3 belts that actually drive the saw blade. I'm going to be replacing those belts also, but in looking at them, they're actually in pretty good shape. But since I have all of this torn apart, I think it's a good idea to go ahead and replace these belts that have been on there for probably over 20 years. With the breaker turned off and the saw actually unplugged from the wall, I want to be able to remove the wires from this motor so I can start to free it up and be able to get this motor off of this saw. Behind this plate is all the different wiring. This motor actually has the capability of being wired to run the 220 volts or the 110. And of course I have it set up for the 220 volt. Now you can see there's just 3 wires here. 2 of them are running the 110 volts, and the third one is the neutral wire. And I need to be able to loosen this clamp also to be able to free up this wire a little bit. There's not a lot of extra room. You may be able to see, I'm going to zoom in, you can see how there's a little metal clip where each of these wires are numbered. That way you can determine which wire is which and be able to determine how you want to wire this motor, whether it's going to be 110 volt or the 220 volt. You can also take a look at these wires and just see just how old they really are, but they're still in good shape. It's time to remove the motor itself. and there are 4 bolts that hold it on. Now this mechanism is a heavy cast iron mount that holds this motor in place. This also allows you to build a tension to belts. As I was inspecting this, I realized it would be a lot easier to remove this cast iron mount with only 2 bolts holding it, and much easier to be able to gain access to than trying to take off the motor with those 4 bolts and leaving that cast iron mount in place. So that's what I'm doing. Now this is a 7/8 inch socket wrench that I'm using to be able to loosen these 2 bolts. In addition to that, it was a lot easier to deal with the belts doing it this method than just trying to take the motor off. But now with this out, I can easily gain access to the 4 bolts that actually hold the motor on. Now this is actually a 9/16 inch wrench that I'm using to be able to remove these bolts. And I think I found some sawdust in here that's probably over 50 years old, because it was definitely caked on really hard and had to be scraped off. Now that all 4 bolts are removed, you'd think this bracket would just lift off. Well, no, it was really stuck on there. So I had to take a rubber hammer and just tap it a little bit and loosen it up. And at that point, yeah, it would just lift off. Of course, you have to get the belts out of the way. And once that's done, then this bracket will just lift off and out of the way. And finally, we're to the motor. The next step is I want to get this cleaned up, all this loose sawdust off of it, and get ready to take it to the repair shop. Now I had already called the repair shop, so they know that I'm bringing this motor in. So I dusted it off real good with a brush, got rid of all the loose sawdust, and I'm ready now to throw this into the car and take it over to them. Here's a look at the data plate so you can see just how old this motor is. So in looking at this data plate, you can see that you have the schematic on how to wire it with all the numbers to be able to get either the low voltage or the high voltage. And they don't make them like this anymore. The components that I had to grease was this area right here, because that was actually causing the squeaking. So there's grease on each side of this. On this bracket that actually turns, I put grease on this, and then there's one on the opposite side the same way, and I greased that. Cleaned it real good, of course, and then greased it. Now it's very hard to see, but down in there are some additional gears that I had to put grease on. And likewise, you can see the shaft right there, and additional grease went in there to be able to take care of all of the lubrication that needed to happen. Now when I bought the dial indicator, it did not come with any type of base to be able to put onto the table saw. This is just the dial indicator. So I went to Thingiverse and looked up some of the work that other people have done, found a table saw alignment jig, and I downloaded that, and I'm printing that out to be able to attach this dial indicator to it. Now while this jig is being printed, I'm going to go ahead and clean up the table saw and get everything in as perfect of a condition as I possibly can while they're working on the motor. As I was searching the Thingiverse, I only found 2 different alignment jigs. And I wanted to take a closer look at this one. I think this will actually work perfect for what I need to be able to accomplish. So I wanted to go into the files, look at each one of the different components, and to me this seemed to be very straightforward. It needed a little support on one of the pieces, but other than that, I think this would be very easy to print out. So I downloaded the files, and you can see right there the files were downloaded in a matter of just a few moments, and I want to give credit to the designer himself. This was designed by Crane Archie, and it's licensed under the Creative Commons attribute, and this is a non-commercial license. I keep all of my files on a USB drive. Now currently it's in drive D. So I'm going to create a brand new folder in the USB drive to be able to keep the files organized. And I'm going to set this up as the alignment jig table saw. Once I have the folder created, then I can take all the different files, including the zip file, and put it into this folder. That way, everything can be found in one place, and I don't have to hunt for it on the drive or hunt for it on the computer. Now this is a simple process. I just highlight the file. Now this is a zip file, and I just hold the mouse down, bring it over into that file folder under the USB-D drive, and that's it. It's now there. And I'll delete this file that is on the computer. I no longer need it there. So now I'll go over to the file folder itself on the USB drive, click on that, and now I can extract everything. So right here, click on Extract All. Just follow the steps, and I'll have this all downloaded into this one file folder. And that will keep everything organized. And from here, I could click on it, open them up, and see what files are actually there. And there you can see all the different files for this project. Now it's time to open the Cura software. I'm going to download all of these different files onto the Cura software. All of these files will easily fit onto this bed at one time. Now this will save a lot of time because I can print everything at once and have the whole entire project done. As I open the different files, it actually places the file exactly where it needs to be on the bed, so there's very little wasted space. Once I have all of the different files opened up, I'm going to make a few adjustments. Now I had recommend to do the infill at 30%. I really don't see where that is a necessity. I'm going to put this at 15% for the infill. I'm also going to add the supports. So when I click on that, it opens up this window. I click on it, and then I can see all of the different settings. I'm really not going to make any additional changes there. I'm going to accept the different settings that are in place and just move forward. The last item that I want to check is the build plate adhesion. I want to make sure that it's set on the skirt. With all these different settings verified, I'm now ready to close out this. All I need to be able to do is hit the slice, and it will process everything in the Cura software. Once that's done, it'll pop up with the menu that says it's going to take 6 hours, 30 minutes to be able to print, and now I'm going to save it to the file. And I'm ready to take it over to the printer and print this out. And of course, I'll save this to the thumb drive should I need to be able to print this again in the future. I've loaded the file into the Neptune 4 Pro. I can now just follow the different steps. I can see the file right here. That's the one that I want to print. So I'll select that, confirm this, and now the machine takes over and it does everything else. The first thing that it'll do is go through the XYZ operation and locate exactly where it needs to be. And once that is done, then it'll start heating up the nozzle and the adhesion plate itself. Now this takes just a few minutes to be able to do. Once it reaches the temperature, it'll begin the printing. Now you can see where the adhesion bed is up to temperature, and now it's heating the nozzle itself. So we're almost ready to begin printing. Once I verify that everything is printing the way it should, I'm going to head back down to the shop and start working on the table saw again. Everything is looking real good. You can see where the skirt printed. You can also see where the support is beginning to print and some of the other components. So I'm real happy with this. I'm headed back down to the shop. So my goal is to be able to create a new table saw as much as I can without buying a new table saw. And it should be fairly inexpensive compared to the price of a brand new one. I really don't want to lose this table saw. It's been in the family for over 50 years. It's a saw that I grew up with, and I still want to continue on using it for many years to come. So a new table saw is not really in the cards. I don't want to go that route. I think it's going to be a lot of fun to be able to upgrade this machine, clean it up thoroughly, get everything greased and oiled, replace every single part that I can that needs to be replaced, and I'll have almost a new table saw. I know I'm not going to take all this apart, and I'm not going to paint this. I really don't see a need for it because it's going to be hidden anyway. But the good thing is I can now raise and lower the saw blade without any squeaking. And then if I want to tilt the blade, Again, no noise, no squeaking. And that's one of the things that I wanted to do. And the only way to really be able to do it was to be able to gain access to the top of the saw. I opened up this switch and actually rewired it. And I've rewired it by being able to use these connectors on the end of the wire and be able to attach it back to the screws on the switch. But quite frankly, this is the original switch. And I think I'm going to actually order a brand new one and be able to have it so I have the safety switch where I can use my knee to be able to bump and stop it. So I think that's going to be a good upgrade. So I'm going to order that today, and I'm not sure when that's going to be able to come in so I can put that on. If it doesn't come in time, I'll just do a separate video on how I install the new switch and replace this one. That's over 50 years old. Now this saw has 3 belts that goes on the pulley that goes and drives the saw blade. Now if you look at these belts, they actually are not dry rotted. They're actually in really good shape. But while I have the machine apart, I think it's a good idea to go ahead and replace the belts at the same time, and I'm just going to hang on to these and have it as a backup. Not that I really anticipate ever having these belts break, but at least I'll have a backup set should something happen. But these belts actually are in really good shape. It's time to check in with the 3D printer and see how this is going. And so far it looks great. So the next time we look at it is when we're going to test it out on the table saw. It's time to test out these parts. And the first thing, the print quality is absolutely fantastic. Very, very pleased with that. Now, this is the part that rides in this track. So let's see how that does. That will work perfect. There is a slight bit of play. So I may just put a little piece of tape on there. But that's not bad. Let's see how this fits. Because this is the real test. And that fits really good. There is no play in that at all. This piece drops in. Perfect. And then that knob will fit on there. So what I'll need to do is get a screw now to be able to go through that. And let's see how the dial indicator fits. Now this is designed so that this will fit right in to this area. And that's actually a little tight. But I can push it in there. That'll hold it. It really doesn't need to go all the way up to that area. So that actually is very workable. This will fit in here. I'll be able to slide this over to where it needs to be to just touch the blade, and then I'll be able to tighten it down so it doesn't move. I think I will add just a slight bit of tape on there. Let's try that and see what happens. I'm going to take just a little tiny piece of the blue tape, and I'm going to put it right here. There is now no movement. That's perfect. So another use for blue tape. I'm going to find a screw to be able to fit through this so I can have a locking mechanism, and this will be done. Okay, at this point you've seen that the 3D printing did absolutely fantastic. And quite frankly, if you don't have a 3D printer in your woodworking shop, you really need to get one. I can't tell you how many different projects that I've done that's really saved time, and it's saved a lot of money. Now this dial indicator, this jig, is working absolutely perfectly. You can see where the alignment on these two components slid together, and it's perfect. There is no slippage at all, there's no play, and that's what you want. That little tiny movement that I had when I put it onto the table saw itself, That's to be expected because there's going to be a little bit of variation between the different table saws that are on the market today. That little tiny piece of tape solved the problem. Now I do need to get a screw. I'll find that later to be able to tighten it all down. So in this video, I hope you've been able to see that we was able to completely disassemble, clean, grease, lubricate everything to be able to get it back in tip-top shape. Part 2 is going to be the reassembling of everything with that new motor. The new switch hopefully will be in by then, and I'll put the new belts on it and show you how to align the tabletop with that saw blade. So I hope that you liked this video, and if you did, by all means, give me a thumbs up, hit the little subscribe button down there, and I can't wait to see it in the next video. So for now, bye-bye everyone. See you real soon.